So, a warm welcome to everyone attending this webinar today. This is the second CSE Development in Action webinar series as part of the 2024 series. Today's webinar, as you can all see on the screen, is on building sustainable and resilient wind energy in India. Today's webinar will be delivered by Commonwealth alumnus Dr. Pradeep Dammala, who is the winner of the 2023 CSE Research Impact Awards in the Topical Prize category for Invest in Our Planet. Dr. Dammala will be speaking about his winning research article on wind energy throughout his presentation. But just to give you a gist about what the Research Impact Awards is, the CSE Research Impact Awards celebrate the research and publication endeavors of Commonwealth scholars and alumni at the early and mid-career research stages. The annual awards are offered through two streams and promote the important research undertaken by doctoral Commonwealth scholars and alumni and its value to international development. If you have missed the January webinar was also delivered by two Commonwealth alumni who were winners of the 2023, who were the other two winners of the 2023 CSE Research Impact Awards, along with Dr. Pradeep. To give you an introduction about Dr. Pradeep is an assistant professor at the Department of Civil and Infrastructure Engineering at IIT Jodhpur in India. His research interests include earthquake-resistant design of structures, seismic soil structure interaction, sustainable geotechnics, and sand dune migration and mitigation. Dr. Pradeep is a 2016 Commonwealth split-site scholar from India. He studied a PhD in civil engineering at University of Surrey and the Indian Institute of Technology, Guwahati in India. I'm also pleased to inform you that Dr. Pradeep was awarded or delivered the CSE Alumni Community Engagement Fund activity to raise awareness on this very topic as well. In 2022-2023, he was one of the alumni organizers promoting awareness in this particular field, and of course, he will also talk about that particular activity, awareness activity in this webinar. So without any further delay, I would now like to invite Dr. Pradeep to begin with his webinar presentation and share with us the highlights of his research study.
Excellent. Thank you so much, Eve, for that. So can you confirm if I'm audible well?
Yes, you are.
Perfect. So thank you so much for everyone who has joined and who are about to join. Thank you so much for that. And I must first thank Commonwealth Scholarships Commission UK for giving me a great opportunity as well as rewarding for the publication and the research work that we have been doing. And I must actually thank CSE for that, as well as the organizing team who have been quite handy as well as quite helpful for all of the proceedings. Now, without waiting further, I would like to take you all through the research that we have been conducting to raise awareness on building sustainable as well as renewable sources of energy harvesting in developing countries like India. So the title has already been discussed by Evangeline. It's basically building sustainable and resilient wind energy in India. So I would like to first take you through the overview of the presentation, in which I'll first of all highlight the need of clean energy sources and why they are beneficial in comparison to fossil fuel-based energies. And since there are a lot of other sources as well in renewable energy, I would like to first of all highlight on why wind energy is, why I have particularly focused on wind energy. In wind energy itself, why I'm interested in offshore wind energy, which is what I'm going to talk about. Since I'm a geotechnical earthquake engineer, I wanted to highlight on the seismic stability of offshore wind farms with a case study in India, for which we have been rewarded for the Research Impact Award for this particular article published in Nuclear Engineering and Design. So I wanted to specially mention my research team because I am the PhD supervisor for my PhD student, Ms. Sumaja Kolli, who is already present here. And I must mention that she is a current Commonwealth split site scholar. So Sumaja is already here. Thank you, Sumaja, for that. Now, once I talk about this particular case study, I will talk about the concluding remarks as well as the summary of the project. And I'll conclude with my research journey, which I started, and how it has been funded by Commonwealth Scholarship Commission. And I would like to finally complete it with acknowledgements. Let us move forward and start the basic of it. So based on our prior experience, as well as a lot of news that we normally hear from the print or national media, what we get to see is that fossil fuels are getting extinct. So let us assume that they're not getting extinct, because we have been continuously consuming them. So if we continuously consume them at the same rate, so what could happen is that all of them can become extinct within this 21st century itself. So what could be the alternate energy sources? So alternate renewable energy sources, which are the best alternatives I would recommend, not just me, like all the climate scientists, that's what they recommend. Wind, solar, hydro, geothermal, tidal, and biomass are the typical different sources of clean energy sources. Let us see some statistics to understand why investing or venturing into clean energy sources are quite important for our greener earth. So if you see the population statistics here, it is always expected that the population will, linearly or reasonably will increase. As you can see here, the dotted lines represent the expected scenario for the next 2050. And then you can also see that the global energy demand is also keep on increasing with a similar trend as per the population. However, as I already mentioned, the fossil fuels are getting extincted very soon. And based on that, we cannot rely any further on the fossil fuels for the energy demands. And it must also be mentioned that the fossil fuel demand, as per the UN climate change impact and other societies and committees, it is going to be almost all neutralized by the time 2050, because we are not going to rely on non-renewable sources anymore. So this particular slide gives us an idea that we cannot rely on fossil fuels for further decades. Now, why we are actually talking about this particular research? Now, my particular focus is basically on wind energy harvesting. I wanted to take you through some statistics. If you see, wind energy is one of the major renewable energy sources with a lot of benefits, which I'll talk about later. So if you see the statistics, with a growth of 6.1 gigawatts in 1996, it has grown up to 900 gigawatts in 2022. And I must say that wind energy can be harvested through onshore harvesting as well as offshore harvesting. But considering that the scientific knowledge that we got currently, onshore is having the major share of energy from the wind energy. So I would like to take you through the benefits of wind energy. If you realize that wind energy is completely free, it is renewable, sustainable, it doesn't emit any greenhouse gases, it's completely climate friendly, it has got no pollution, no waste, energy efficient than all the fossil fuels, and it can be installed at any remote places, most likely onshore or offshore. So with these so many benefits, why not venture into something that is always reliable and sustainable? Now, let us see how the wind energy harvesting has been evolved with time. So if you see, this particular concept of wind energy has been originated from windmills concept, which is basically conversion of kinetic energy of mass of air. So the first operational wind turbine was developed by Professor James Billet in the late 19th century. And if you see, compared to that, in 2022 alone, around 78 gigawatts of wind energy was harvested, which is approximately 9% of the total wind energy which has not been harvested till date. The first, as I mentioned, the first wind turbine, which is actually published in the book of modern engines and power generators, which I mentioned here. This is a typical operational wind turbine that was utilized. And with increase in the demand for wind energy, there has been a significant raise in the type of wind turbine structures as well as their relevant rated power as well. As you can see here, initially the rotor diameter, the wind turbine blade and the rotor diameter itself is somewhere around 15 meters, which is currently at the rate of 250 plus meters, the wind turbine rotor diameter itself. Because the rated power depends on the wind turbine diameter as well as the height and geometry of the wind turbine. So meaning that the wind turbines are gradually evolving, for which their designs and stability should also be similarly looked into. Now, let us see offshore wind energy, because that is what the complete research article is based on. So offshore wind energy is most efficient, consistent, and it does not have any site constraints. And moreover, it has got less shear resistance in comparison to the onshore wind energy, because the shear that is available, that is currently prevailing on the onshore, I mean, on the ground, is more in comparison to the shear on the shear force on the sea. So as you can see on the left, the first picture here, let me take you through this. Yeah, there's a pointer. As you can see, there are different types of loads that need to be analyzed whenever we plan to design or analyze a particular wind turbine. So as you can see here, there are different loads like the wave load from the sea, and the wind loads from the prevailing winds, as well as the self weight, as well as the movements that are existing from the particular wind turbine itself. In addition, there could be loads from any earthquakes that can happen in the particular region. There could be loads from the tsunami, loads from the hurricanes, cyclones, and all those things. These are quite additional to the region-specific nature of the wind farm that is located. Now, what are the different components that are involved in a particular wind turbine structure or a wind farm? So as you can see, this is a particular wind turbine for which the wind energy will be harvested and transported through different cables to the onshore, and it will be stored and distributed via different substation lines. And the most important challenging aspect of design of a wind turbine in offshore is basically the type of foundation. So as you can see, there are different types of foundation that are already existing in the literature, and they all depend on the type of structure and the depth of sea where it has to be located and things like that. Now, because my focus is basically on seismic safety, basically earthquake safety of offshore wind turbines, I wanted to highlight why seismic safety is important for offshore wind turbines and why that must be considered. As I keep mentioning that wind turbines the size of wind turbines keeps evolving. As you can see on the right hand side, the wind turbine, the transportation of a wind turbine, how challenging it is. Let us see, there is a curve here. The wind turbine has to be quite strategically planned for transportation whenever they have to be located and installed. And just for a comparison purpose, I wanted to highlight here the height of Eiffel Tower is currently 324 meters. Of course, it ranges deep, plus or minus few meters depending on the thermal temperatures in the particular region. However, the average height of Eiffel Tower is 324 meters. And if you see, the current existing maximum wind turbine rotor diameter is approximately 260 meters, which is not so different in terms of the height of Eiffel Tower. So I wanted to make you feel how big a wind turbine could be. Now, why I'm actually pressing on the seismic safety is that many countries, like many developing as well as developed countries, like, so if I want to talk about USA, which is already, you can consider developed, it is basically, so this particular map highlights or talks about the seismic nature of the particular region. The reddish spots highlight the predominant seismic regions, and which are basically quite quite close to seismic faults. So many of the countries which are quite close to those seismic prone regions are actually venturing into offshore wind farms. So that is my overall focus of the study, wherein in addition to the existing complex dynamic loads, what if these structures are located in these kind of seismic prone regions? Will there be impact? Will there be sufficient stability and things like that is what my research talks about. Now, so since we talked about offshore wind farms, I wanted to also take you through nuclear infrastructure, which is, of course, not in very much connection with this, but there will be an integration, which I'll talk about in further slides. Now, I'm sure many of you may have heard about nuclear infrastructure, and many of you may have realized from reading local newspapers or from your understanding itself, nuclear infrastructure is quite critical in nature because of the chain reactions and lot of exothermic chain reactions, as well as the environmental aspects of this nuclear infrastructure is often being questioned by local public as well as many scientific bodies. Now, I also want to stress upon a few aspects of nuclear infrastructure. So many countries, like again India, Japan, UK, and other countries are, despite located in seismic prone regions, yet they are still venturing into nuclear infrastructure to meet the demands of the energy in the particular region. Now, so India, I wanted to highlight Indian part. If you see, India has got a long coastline, more than 7,500 kilometers of coastline, basically a peninsula, I would say. So with that long coastline, India has already got many operating nuclear power plants, and there are few more nuclear power plants that are yet to be installed because they have been finalized, or their locations are also finalized. Now, similarly, Japan. So Japan has got a couple of many nuclear infrastructure as well. So now moving forward, why nuclear infrastructure are critical and why strengthening them is strengthening them against seismic loads or things are quite important. As you can see here, so I wanted to particularly talk about a nuclear failure that has happened in Japan in 2011, Tohoku earthquake. So if you see the past three major nuclear power plant disasters, you could realize that the first nuclear disaster has happened in 3 Mile Island, 1979, as you can see here. And the major reason for that is loss of coolant power, because as I mentioned already, due to the continuous heat of hydration as well as the exothermic nature of these chain reactions, there is a continuous supply of power required, continuous power supply of water that is required to keep the chain reactions in control. So for which you need continuous power supply, and this power supply will have different levels of safety always for this critical infrastructure. However, the past three nuclear disasters, as you can see, their impact was also mentioned here clearly. They highlighted that the loss of power during such impacts was the major reason for the disastrous nature of this particular three nuclear power plants. Meaning, if we can somehow uh, make alternatives to provide continuous power, even because I must mention that these nuclear power plants should not be off even for a minute, even for seconds. So that is a reason that there has to be continuous power uh, being supplied to these nuclear power plants despite any kind of a scenario. So if you read some articles on this nuclear power plant safety, you will realize that how relevant or how robust their designs would be. Despite being so robust and so resilient, yet there have been significant failures which have happened in these nuclear power plants. So this is one picture I wanted to highlight, which has happened during Japan 2011 Tohoku earthquake, which actually led to 166 USD billion damage, as well as more than 1 lakh people got evacuated from the particular region. Now, if you see, so can you see my title? Because somehow I.
Yes, you can see it. I can see
Okay.
it at least.
Okay.
If attendees cannot, please let us know in the chat box. Thank you.
Yeah, because I cannot see my title because this is completely being occupied. I think that's okay.
This is fine. Yeah, this is fine. We
Okay.
can read it. Yes.
Sure, perfect. So thanks for confirming that. Now, moving forward, as I keep mentioning about Japan Tohoku earthquake, I wanted to stress on a particular aspect of wind turbine integration with nuclear power plant. So Japan, just to give you a brief background, Japan was hit with a moment magnitude 9 earthquake on 11th March 2011, so which induced tsunami waves, as probably many of you might have known that. So in that particular, during that particular earthquake, there were a lot of infrastructure that have been lost, impacted, structural damage. As you can see, the entire structural building, which is completely uprooted due to the earthquake as well as the tsunami. You must have, this is the famous picture many people use to define or represent Japan's Tohoku earthquake led tsunami waves. And the biggest positive that one of my collaborators as well as my PhD supervisor in UK, Professor Sumay Bhattacharya, unfortunately, he was present during the earthquake in Japan during this event. Fortunately, he was technically sound and healthy, but he took it as an opportunity to visit many places which have been affected. He was the one who took this picture on the left hand side, and unfortunately, because he works on offshore wind turbines, he visited an offshore wind turbine which was not even disturbed or impacted by this particular biggest earthquake in the Japan. So then he got an idea. So why this particular wind turbine, despite staying quite close to the epicenter of the earthquake, why did they not fail? Then he started digging a little deeper and to understand the basics of this and the physics of these wind turbines. Then after analyzing the spectral acceleration, because let us assume that this wind turbine is a single degree of freedom system body, and since they are so tall and so flexible, their fundamental frequencies are quite long enough, and they're not matching, as you can see here, they're not matching with the fundamental frequency of the earthquake, meaning they did not come into the resonance effect, and that's how they got saved. So, but based on this particular preliminary understanding, he proposed, then why not integrate this particular wind turbines as an alternative solution or alternative backup power source to the nuclear power plants, so that they will not be impacted, or they'll keep running even during the earthquakes or tsunamis or cyclones, things like that, because they are quite operational. The wind turbines are quite operational. So this article, the idea was published in 2016. I must mention here one thing, that we have a journal called Soil Dynamics and Earthquake Engineering. Is quite prevalent as well as quite prominent in geotechnical engineering. This particular idea, which was conceived by my professor Sumay Bhattacharya, he submitted the idea to the journal tonight, and it got published. It got accepted on the next day. So ideally, this particular journal would take no less than 6 months to 8 months to publish. Imagine the impact of the idea, that the editor himself accepted the article within one single night. So that much impact this particular article has given. But that's just a basic idea. Now, when I went to UK to further extend my research during funded by Commonwealth Site Fellowship, so then I conceived this idea: why not understand this little further, and why not do some case studies across the world to make people aware that why not venture into wind power and make this globally visible. So with this idea, once I finished my graduation PhD from UK and then came back to submit my PhDs to IIT Guwahati, then I got absorbed at IIT Jodhpur. Then I had my own research team, and I gave this as a solution to one of my PhD student, Ms. Sumaja, and she started working on it. We formulated a strategy called a seismic resilience strategy, in which we have taken a case study from India, southern part of India, where there is already a nuclear power plant existing, which is called Madras Atomic Power Station. So it's basically a nuclear power plant in southern part of India, which falls into the seismic zone 3. As you can see here, yellowish zone is the location of the nuclear power plant. Now, okay, we realize that there is a power plant, but there are no wind turbines in India. There are no offshore wind turbines in India. We wanted to stress, and we wanted to make this aware to the public and the general stakeholders. Now, the proposed idea is that first of all, we need to understand what is the type of nuclear power plant. We need to estimate the required coolant power for a particular nuclear power plant, depending on the type of reactors existing in the nuclear power plant. And then we need to see whether the existing wind turbines can cater to the required emergency power of a particular nuclear power plant or not. And then once we realize that, we need to then design the foundation aspect of the wind turbine. We need to decide the type, size, geometry, and then we need to do an integrated seismic analysis considering the local geology, soil, the seismic conditions, the expected wind loads, expected tsunami loads, expected meteorological loads, expected wave loads, everything together. Now we made a strategy which is basically a seismic resilience strategy, in which all these aspects have been briefly mentioned. So this has been published in the journal, which won the RIA award. And I would request, if any of you wanted to have a go look, you can please, you're requested to do so. Now, because this is the overall flow chart, I would like to take you slowly through the flow chart. I'll not be too technical on this aspect. I'll only be touching about few important aspects of it. Now, considering the case study, we realize that it's basically a FBR reactor, which is basically fast breeder reactor in the MVAPS nuclear power plant, which for which we calculated the required emergency power, which is based on the pumping requirement, coolant requirement, and others. It has come close to 15 megawatt. So we realize 3 megawatts National Renewable Energy Laboratory, NREL they are called. Why 5 megawatt NREL wind turbines will cater to the needs of this coolant power. So then the next task is to design the foundation for this, considering the tidal, meaning we have collected over 20 years of wave height in the particular region. We did risk reliability analysis for that particular wave height. We identified what are the critical aspects of it. Then we did collect a lot of soil data in the particular region, because there is always, as you can see, there are around 20 meters depth of the soil below the sea level that has been collated from various literature as well as some site visits. And then we did some deterministic as well as probabilistic seismic error analysis for the particular site, meaning we'll have to forecast, considering the location of the site, we'll have to forecast if there could be any earthquakes that could arise or that could hit that particular site. I must mention here that despite this southern part of India staying, located in relatively less earthquake prone region, but critical nuclear infrastructure are quite critical, as I mentioned. Even the smaller things should not be neglected for its criticality. So that's why we had taken everything into effect. So all these loads have been considered for the design. Now the next part is we need to model this entire in a finite element continuum analysis. So for which we also consider the liquefaction, because whenever we talk about the soil, we talk about earthquake, we also need to look about the liquefaction, meaning the soil becomes, because soil is basically a solid, it becomes like a liquid whenever there is a impact of earthquake dynamic loads. Depending on the type of load, depending on the intensity of load, the soil might become like a complete fluid. So that is what is called liquefaction. So that aspect is also being considered, and we check different intensity of earthquake starting from smallest 0.08 G, which is basically measured in terms of peak ground acceleration. As you can see here, we started with the smallest earthquake that could happen at the location, and we went up to the maximum earthquake that could happen at the location, considering its seismicity for that region. Now, following that, we developed Winkler soil models, which are basically soil structure interaction. We did free field ground response analysis. We calculated all the amplifications, attenuations of the particular site. Now, we also, even before you develop any numerical model, I'm sure many people who are working on continuum analysis would realize that their model needs to be first of all validated. So for which we actually validated our model with published results of Bollinger et al., which was basically centrifuge data from 1999. And we did a complete integrated seismic analysis with considering all the bending moments, tilting, because we have to ultimately do a performance-based analysis for the wind turbine. We compared the expected pile as well as the wind turbine displacements and pile rotations. We realized that these are basically the expected or anticipated or induced movements and pile displacements will be in the overall capacity or overall safety levels of a particular wind turbine. Now, having known this from our basic results, we realize that yes, 3 megawatt NREL turbines can power the MAPS nuclear power plant for its coolant power requirement. That's what we realized. So we also realized that this particular 5 megawatt turbines can sustain any future expected earthquakes, considering the uncertainties that we looked into. We also realized that seismic liquefaction will not be so impactful, considering the proposed wind turbines. So these are overall wind turbine, because we propose 3 wind turbines as integrated system, which is basically offshore wind farm, I would say, which are with the dimensions of so and so. 63 meters is the blade length, and 87 meters is the hub height to the monopile height, and then 15 meters depth in the soil. So this is the overall summary. And once we realize that, how will we take it forward? Because this is basically research. How will we take it forward? For which we realize that India has got more than 7,500 kilometers of coast length. Then we wanted to take it forward, for which we got the ACEF Alumni Community Engagement Fund from Commonwealth Scholarship, and they helped us organize the event, which was widely spread, widely advertised, and attended by more than 200 participants from 14 different countries. I must mention that, and many people have showed interest. Many people have, through the feedback, we realized that many people wanted such kind of workshop for enhancement and then wider publicity. After completion of the workshop, we had done post-workshop sessions with stakeholders, and we realized several challenges. What are the challenges that are currently backing the wind power, offshore wind power harvesting by several countries, so which I will talk about in a Q&A session. So the post-workshop sessions were quite impactful as far as I understand. Now we are actually scaling up to different locations in India. We wanted to highlight on different case studies, which includes tsunamis, which includes hurricane effects, which includes many other uncertainties in different regions of India. Now, this being said, so this is the overall summary of the research article that's been published, that's been awarded for the Research Impact Award. Now, I must thank few people as well as organizations. So first of all, I wanted to thank Commonwealth Scholarship Commission for sponsoring 1 year of my Commonwealth Split Site Fellowship during 2016-17. So I always cherish those moments. The left one, highlights basically my 2016-17 tenure as a split site scholar. Because we had a welcoming event at Nottingham, I believe. So that's where the first left picture is. And the right picture is basically where we conducted the workshop on 4th February 2023, exactly a year ago. So it was funded by Commonwealth Scholarship Commission. I must always be thankful for that. So in addition to that, I must thank many people who helped me achieve my targets, and they keep pushing my boundaries always. So my PhD supervisor in India, Professor Murali Krishna, he's currently at IIT Tirupati. He has been one of my greatest pillars of support. And of course, my other supervisor from UK, who has been my split site supervisor as well from University of Surrey, UK, who was the main one who conceived the idea of integrating offshore wind power for enhancing the robustness of nuclear power plants and resiliency. And of course, my research student, and I must say research group mate, Ms. Sumaja Kohli, who is currently following I wouldn't say my footstep, but she herself got Commonwealth Split Site Fellowship. She's currently the Commonwealth Split Site Fellow at University of Birmingham, UK. She's already present in the current participant list right now. And I also wanted to thank CSC, because the workshop that we handled and all the research that has been published was highlighted by many national newspapers, electronic print media. So which basically talks about, because this is one way we can actually focus on bringing enlightenment to the public. So we can actually bring this closer to the public. So this is one way that many newspapers have taken our consent for publishing, and they made it sure that people could read it. Yeah, they actually publish it in local languages as well. So finally, I want to cherish many of my Commonwealth scholarship memories. The left first one was the Nottingham welcome event in November 2016 when we just joined the University of Surrey. They actually sent us tickets and everything to join for the welcoming event, where every one of us, including full-time fellows, everyone got great welcome basically. And then I also had the privilege to attend a CSC workshop on sustainable development goals in February 2017 during my tenure at University of Surrey. So I also had the opportunity to visit to attend the CSC farewell event in 2017 June. So with all this, I always cherish these moments at University of Surrey, funded by Commonwealth Scholarship Commission. And since then, I've been following the newsletters of Commonwealth Scholarship. Whenever there is an opportunity, I always push my application. And thankfully, both my applications have been awarded. And in fact, my student's application was also awarded for the split site fellowship. So with this, I would like to conclude, and I must thank every one of you for joining. I also wanted to thank CSC again and my research team and all the participants again and again. Thank you so much, everyone. So I leave it to AU for further.
Thank you so much, Pradeep, for this wonderful presentation. And I think it just speaks volumes of your research study, but also I hope this has encouraged our scholars and alumni to participate and engage in various CSE activities. And yeah, thank you so much for sharing your work on last year's CSE Alumni Community Engagement Fund as well. For those who would like to know more about Pradeep's ASEF activity, which is the Alumni Community Engagement Fund activity delivered last year, you can read the report on CSE website, and I'm happy to share this in the chat box for everyone to just access directly. Yep. Yep. You'll find the link to Pradeep's article on or promotional awareness activity on the website. Great. Uh, Pradeep, if you are ready, we can start with the Q&A session. First of all, thank you to everyone who have sent in their questions in advance via the registration form. We will begin with a few questions from there, but also please do send in your questions in the chat box. I'd also like to invite Sumaja for the Q&A session, and Pradeep and Sumaja would be happy to address any questions you may have regarding to the research study, the winning Research Impact Award article, and Pradeep's work in general. And Sumaja's inputs as on this will is appreciated as well. Pradeep, all right. So the first question is, how environmentally friendly is this particular resource, is wind energy?
Yep. Well, as I already mentioned in my previous slides, in comparison to fossil fuels, it is more than 99% efficient because it doesn't emit any greenhouse gases. It is quite environmental friendly. It is always sustainable. It is free of cost, no greenhouse gases, as I mentioned it. So it's quite environmental friendly. Of course, every energy that you normally harvest will always have minor cons as well. But in comparison to the benefits that it provides, when comparison to fossil fuels, it is 19% beneficial.
Thank you. I think someone also wanted to know, which are the, apart from your institution where you have pursued your studies, where can, if you can name a few institutions who provide courses in this particular field for PhD specifically.
Perfect. So are you referring to offshore wind energy domain
Yes.
specific, universities?
Yep, offshore
Yep.
wind energy.
So first of all, Europe has been evolving as well as the forerunner in terms of offshore wind energy harvesting. Fortunately, UK is the front runner, I would say, followed by Denmark, Netherlands, Denmark and other countries. Recently, the USA also started venturing into it, and then China is also one big nation, as well as Japan. Now, considering that, if you're talking about specific UK, I would say Cambridge University has got quite good experimental facilities as well as numerical modeling facilities in terms of offshore wind energy research. And I specifically want to highlight here University of Surrey, where Professor Sumai Bhattacharya was the leading leader in this particular area. This particular Professor Sumai Bhattacharya is one of the top 1% of the entire globe in terms of offshore wind engineers. So in terms of expertise, he is considered one of the topmost experts, and his laboratory is well equipped with all the elemental testing facilities across the globe. I must say that. Why? Because I myself have used them, and I must say that not many universities across the globe will have all of these facilities imbibed together. So University of Surrey is one, University of Nottingham, and Cambridge, Oxford in UK. These are quite good universities where I visited personally. In addition to that, China has got very good China, Japan, and of course Denmark, and then recently Norway, and as well as Delft, because Delft is one of the best research nations in terms of offshore wind energy, as you would realize. So these are few countries which already are forerunners in terms of research and development's wing of offshore wind energy. Recently, of course, developing nations like India started venturing into it, but our developing nations are actually taking the help of developed nations in terms of offshore wind energy to lend hand in terms of technical knowledge transfer. So with my understanding, there are few universities which are already excelled, and they are giving very good consultancy as well as research and development wing support to many industries for the offshore sector.
Great. Thank you so much for that response. And I hope, if you are a master scholar, specifically, pursuing a study in this field, I hope you are motivated to look into this further, and perhaps apply for your PhD studies in the future. Thank you so much, Pradeep. The next question is, what has been the approximated impact of this particular project? What has been the impact of your research study?
So I always feel privileged to actually answer this question. Why? Because this is the work that I actually took it to heart, and put a lot of efforts to bring it to the public. And particularly, I must thank again the CSC for making it visible across the country as well as across the globe. Now, having said that, we started with a very small case study, which has been widely publicized, widely received by a lot of stakeholders. Now we are actually planning to upscale it through various case studies across India, first of all, because as I said, in India, we don't have any offshore wind development yet, but there have been plans at two different states of India. One is in western part of India, which is in Gujarat, and the other is in the southern part of India's Tamil Nadu. So these two locations, the preliminary studies have been conducted by European Union, by the support of European Union. So there are already sites that have been identified, but we, as I said, we are still depending on European Union for the technology transfer. Now, with this said, so we are trying to upscale this so that we will let the government and the stakeholders know that we are also becoming self-sufficient, knowledgeable enough for us to make things workable as well as designed from India itself. Of course, the basic idea and basic expertise has been gained from my foreign exposure. I must accept that, but still, we are making things workable from Indian platform itself. So now we are taking it to different stakeholders. We are meeting people. We are understanding the challenges. Once we realize this challenge, we can actually work on their challenge for taking it as a research problem, and then solve the problem for their physical implementation in the field. So that's what our future plans are. We wanted to upscale it slowly, gradually.
Thank you so much, Pradeep. I would now like to I'm just scrolling through the questions in the chat box. I would now like to invite Miracle to unmute themselves and ask their question.
All right, thank you very much. Hi, Pradeep, can you hear me?
Yeah,
Yes.
hi. May I know your name?
Miracle Mbekwe.
Oh, hi.
Okay,
Miracle, hi.
so yeah, my question is, considering that wind is regarded as one of the most intermittent sources of energy, and you want to depend on it for a nuclear power plant as a backup plan to cool a nuclear power plant when something goes wrong. So what if on the day that you need the backup power to come into play, that you don't have enough wind on that day or on that week? So what is the solution?
Okay, excellent. In fact, that's an interesting question, Miracle. So I must tell you that, see, basically nuclear power plants will have three different levels of safety for emergency backup power. So they got first safety, which is basically direct power. Then they'll have emergency backup power, and then they have DG sets as well. So they got three levels of safety, and our level of safety will be the fourth level of safety. This basically will be the wind power integration will be the fourth level of safety, meaning that we are trying to enhance the power efficiency or maybe resiliency against a particular event. As I said, my research article was based on earthquake based event. So let us say there could be an earthquake, and then because offshore wind turbines are found to be resilient on a regional scale, so they could be an alternate sources during earthquakes, considering there could be a possibility of loss of power for the three levels of safety. But as you rightly mentioned, there could be a possibility that there could be less wind. There could be any other factors which could lead, which could stop the functioning of offshore wind turbines. But there is one risk that we must always accept. That is the reason we are actually upscaling it with considering risk and reliability analysis. We are actually intending to include that aspect as well as one of the factors of risk and reliability of offshore wind energy when we integrate it with nuclear power plants. So thank you for the good question. That's interesting question. I realize that you have been following it well. That's how you could formulate it.
Yeah, thank you very much. If you don't mind, can I still ask one more question?
Yeah, go for it.
Okay, sure. So I also wanted to find out what is the wind potential of India, because I'm aware that around the Pacific zone, the wind there is not so fantastic. And if you don't mind, I don't know if you've also had an opportunity to make a research into the wind potential of tropical countries around the Atlantic zone. So if you can just give me your insight on this question, that would be nice. Thank you.
Yeah. Thank you, Miracle, again. Thank you so much. So, this particular wind potential evaluation, are estimating the wind in a particular region is not my area of expertise, but I would say that I'll give you an example of India. So what happened is Indian government, they they formed a consortium with European Union, and they made a project called FOWIND. FOWIND, FOWIND project. It was funded by European Union. It started in 2010, and they did these preliminary studies across the entire peninsular India, coastal line of India, to realize the wind potential. And they found out that at particular locations like Gujarat, which is basically the western coast of India, similarly the southern part of India, Tamil Nadu, could be potentially, the wind from these two locations could be potentially are initially started to venture. So as I said, since I'm not an expert in this area, but I've gone through this report and realized that wind in these particular regions could be potentially harvested. But unfortunately, I could not answer the second part of your question because I did not go through any of the reports on the other parts of the globe in regards to wind energy harvesting or feasibility studies of wind energy potential. I would suggest you to look into the reports or the research articles which highlight feasibility studies for wind energy harvesting in tropical or other related countries.
All right, thank you very much, Pradeep.
Thank you.
Thank you, Marika, for your questions. Pradeep, just following that, I think I'm not sure if you'd be able to answer following your recent response. But the next question is, in terms of the power volumes, can wind energy power entire cities, especially in the context of, if there are countries that are inland, such as Zambia?
Yes. So here, if you're talking about inland countries, if they don't have any offshore or shore, basically coastline, so onshore wind, as far as current existing standards, current existing statistics, 90% of the wind currently being harvested is basically from onshore, because onshore wind has completely or mostly researched and very well established. So many countries, even 10%, I must say 10% of US electricity is currently based on onshore wind energy alone. So if a country like US, with so much of diversity, is already ventured into wind, and 10% of the entire electricity is being contributed by wind, why not other countries, inland countries? It is doable. It is doable. But there are little challenges associated. Why? Because investing in wind energy is little, but it's not so budget friendly in the initial stage. But considering its maintain and cost benefit analysis, it is profitable in terms of long run. Initial investment could be little higher because you need a lot of infrastructure which needs to be functional. You need manpower to monitor it, things like that.
Great. Thank you so much, Pradeep. Moving on, the next question is recent studies have correlated rising global temperatures with changes in wind in various regions. How sustainable will the wind energy project be in your view?
Yes. So I mean, if I understand correctly, probably this is in terms of comprehending climate change impacts on the wind energy harvesting. Well, if you ask me, rather than venturing into something that is going to be extinct, like fossil fuels, why not look into something that will always be existing, whether it is at 0.1% or 10% or 100%. It is always beneficial to look for something that is always green. So I wouldn't look into the aspect of how beneficial it would be. I would rather look into how greener it could impact. Ultimately this will help reduce the climate change impacts, right? So it will always be beneficial in my sense, but I will leave it to the public.
Great, thank you. I'm not sure if you would like to invite Sumaja to respond to any queries, or also explain what her role was in this research study. Sumaja, would you like to share your just a few information about your research work and your contribution to this research study and what you're currently doing as a Commonwealth scholar currently?
Yeah, hi everyone. I'm Sumaja. So, as Sir has introduced, like currently I'm working as a Commonwealth split site scholar at University of Birmingham. So I'm currently working on the sand dune migration and mitigation, which is also related to sustainable geotechnics. So with regard to this project, like the offshore wind energy and its integration to nuclear power plant, I worked on this for my master's thesis. That is where I joined under the supervision of Dr. Pradeep, sir. So during this project, I got to, see my specialization is basically in energy. So having worked in both energy fields and looking at the sustainable aspects, I think this gave me a very new expertise, very enriching knowledge also. And yes, CSE, I think this publication and everything has helped me in the process of my application to CSE also. I think all these projects and the relation to sustainability will always be benefited, not only in terms of application for the future also. So yeah.
Great. Thank you so much, Sumaja, for giving a quick overview of your study. Pradeep, maybe we'll have one last question. I don't see any more questions in the chat box. I'll go back to the list of questions that we received in advance. So probably one question from there. Could you tell me what backs the current administration of wind project constructions across India, and what is the main bottleneck to be addressed while implementing these projects?
Well, to answer this, I would like to take you to some government, because there should ultimately be a support from the government whenever you talk about harvesting something new, because Indian government is quite supportive in that nature. Why? Because as I said, they got in hands with the European Union. They developed this feasibility report on this supervision, and now they started subsidizing, because they started subsidizing the firms whoever want to venture into offshore wind energy. So that is how they are actually bringing many global partners on board. Earlier, this has not been the picture. And this is in terms of support from the government. But in terms of technological as well as logistical challenges, I must mention that these wind turbines, the technology, be it their design of the blades, or even for the infrastructure, let us say a big a support system is required to transport a particular wind blade from the onshore to the offshore. Because let us say you have to install a wind turbine at 20 kilometers in the sea. So you need big jetties, basically. You don't have a big jetty in India, as far as I understand, because during the workshop that we conducted, we have been talking about these challenges, which are actually hampering the offshore wind energy growth in India. So many industry people wanted to venture into it, but they don't have sufficient infrastructure, not yet established in the country. So that is one big bottleneck, which is stopping our, which is at least till now. But I'm sure this scenario will change, and it will progress. It will help people to realize the challenges, and many companies are coming forward to venture and invest into offshore wind energy by constructing all their infrastructures by the support of the government.
That's amazing. Thank you for sharing that information. I think with this, we will now end our Q&A session. But before that, once again, thank you so much for all the questions that you have sent through the chat box as well as via the registration form. And Pradeep and Sumaja, thank you so much for responding to queries and sharing details about your work. Pradeep, once again, congratulations on winning the 2023 CSE Research Impact Awards. For those of you who would like to learn more about Pradeep's winning research article, I am going to share the link of the article or the report on the CSE website in the chat box. Please do have a look at his research paper and what the Research Impact Awards is all about. I'm also, again, resharing Pradeep's CSE Alumni Community Engagement Fund activity report, which is, again, available on the website. So I'm just sharing the link with you. There you go. So yeah, thank you so much, Pradeep, for this wonderful presentation on your research study and for continuously, engaging with the CSE community, for sharing your work, your research study. As you can see in the chat box, your presentation has been appreciated by everyone. As you know, Sumaja is currently in the UK pursuing her studies. So if you are a current Commonwealth scholar, and if you are attending the upcoming CSE Connect and Collaborate event, I believe Sumaja is attending the welcome event on Friday.
Yeah,
Great.
I'm attending it.
Yes, amazing. So if you're a scholar, if you're attending the Connect and Collaborate event, please do look out for Sumaja, say hello to her, find out more about her research work, and the collaborative study conducted with Dr. Pradeep. Pradeep, once again, thank you so much. As I've mentioned, this webinar was recorded, is being recorded. I'll just stop the recording now. Okay. The webinar is recorded, so we will share the recording on CSE's YouTube channel. So please, if you would like to know more, please do access the recording on the YouTube channel shortly in a few days' time. But thank you once again for joining this live webinar and for sending in your questions. And we will see you next month with another webinar topic. Thank you, everyone.
So thank you so much again.